What's up, guys? Today we're going to combine functions. A little bit different kind of day today, so really pay close attention. There's some new things, so hang in there. All right, algebra functions. First of all, we're going to do a few things here. We're going to combine functions by adding them, subtracting them, multiplying them, dividing them, and also finding the domain. Now, when you add the two functions, we're literally just going to add the two. When you subtract them, we're literally just going to subtract them. When we multiply, we're literally going to multiply them. When we divide, literally divide them. The domain is going to be, remember this symbol, means intersection, What the domain is what the two domains have in common. That would be your domain. Except for the last one. The last one when you divide is also what they have in common, but also it cannot make the denominator equal 0, obviously. So you may have to restrict the domain just a little bit more when you divide. Let me show you a couple examples here. All right, it says f of x is 1 over x minus 2, and g of x is square root of x. And what it tells us to do is find f plus g, f minus g, f times g, f divided by g, all the f and g's. Okay, so let's go first of all. First of all, we're going to go f plus g. And it also says find the domain. So part A, f plus g is just going to be 1 over x minus 2 plus the square root of x. We're going to leave it like that. The domain, first of all, the domain for this first one would be x is not equal to 2. And for square root of x would be x is greater than or equal to 0. So what we would say for our domain there, we'd say, okay, everything from, need a bracket, from 0 to infinity, except you've got to skip 2. So I'm going to write like this, 0 with the bracket, 2 with the parentheses, so it doesn't include the 2. Then we're going to go from 2 to infinity. And that represents all of that. Part B, f minus g is going to be the same answer here, except with a minus sign. And because it looks exactly the same, the domain is going to be exactly the same here. Part C, f times g, I would say 1 over x minus 2 times the square root of x. When I work that out, the square root of x would go to the numerator, the x minus 2 would go to the bottom. The domain, again, is what they have in common, which we've already talked about up here. And I think we're still okay there. Still okay to put the same thing because 2 would make the denominator 0, which 2 is not included anyway. So I'm going to use these same symbols for that. And we got one more part here, part D. Part D, where we're going to say f divided by g. So I'm going to say 1 over x minus 2 divided by square root of x. And what happens there, remember when you divide fractions, you multiply by the reciprocal. And the only difference here is also now that the square root of x is in the denominator, x cannot equal 0 because that would make me have a 0 in the on the denominator of the fraction. So my domain is going to be everything from, well, let's just change one thing here. I think we're okay, and I just kind of messed that up. If we just change it to where it doesn't include the x, like we do this, it also cannot be 2, but it can be anything between 0 and 2, and then we start at 2, and we can go forever. All right, so that's the only change there. A lot of thinking there, and we'll work on some of it tomorrow. One more thing, it does say, I'm running out of room here, but it does say to find f plus g of 4. So what I'm going to do there, we'll do this in class tomorrow, is I will take the 4 and plug it in for both x's. We'll do this first one. If I plug 4 in here, that fraction, I'd get 1/2. If I plug it in there, square root of 4 is 2, so I get 2.5, which is really 5/2. Okay? And that's all you do in all of them. You'd plug 4 into all the x's and just get that value, which we kind of did yesterday. But after you've done the work, the f plus g, the f minus g, the f times g, plugging the 4 in is not that big a deal. All right, composition of functions is when you plug one function into another. It says given two functions, the composite function, and the way you say that is called f of g. F of g, like when you see this f of g. You can also write it like this, f of g of x. That's called composition. The way it works is we're going to take function g and actually plug it into function f. Function g into f. The domain is a big deal here. Make sure you get this. The domain of f of g, or the composition, is all the x's in the domain of g. So we're going to take the domain of g, what we're plugging into the other one, such that g of x is in the domain of f. That sounds real complicated, but it's not. We're going to we're going to find the domain of g. We're going to plug it in, get our final answer, and then figure out what part of the domain of g is still in our new function. Okay, so it's kind of what they share. Best thing to do is show you. So here comes one. Okay, so it says, one of them says, let f of x equals x squared and g of x equals x minus 3. find the function f of g and g of f. So when we're going to find f of g, I'm going to take function g and plug it into f. It's going to look just like this. So if I plug function g into f, I'm plugging it where the x was. So I'm taking that and putting it right there where the x was. So it's going to be x minus 3 squared. This would be x squared minus 6x plus 9. That's f of g. Okay, when we find g of f, we're going to go just the opposite. I'm taking f, plugging the g. So I'm taking the x squared, I'm plugging it right there. So it just look like x squared minus 3. All there is to it. Okay, now part B says find f of g of 5, which is exactly, that's what this is. That's f of g. I'm just going to plug a 5 in there. So I get 20, well, I get 25 minus 6 times 5 plus 9. 25 minus 30 is negative 5 plus 9, that's 4. Then it says to find g of f of 5. Okay, so I'm going to find, that's g of f. So I'm just going to plug 5 in there. 25 minus 3, 22. All you got to do. Okay, so hope that made a little sense. F of g, g of f, you got this. Okay, really watch this one. Find everything you see there and find their domains as we go through. So I'm going to find f of g, g of f of f, g of g, all that stuff, and find their domains. So watch how this works. First of all, A says f of g, which means I'm plugging g into f. So I'm going to get the square root of 2 minus x. Okay, so I basically just plugged in g into f. Now, what that really equals, because it's 2 square roots, it's really a 4th root. Okay, now, let's just find the domain. First thing I need is the domain of g. The domain of g, because there's a 2 there, that's got to be positive. So if I came down to the side somewhere and it's okay, 2 minus x has to be greater than or equal to 0, and I move the x over here, there's my domain. X has to be less than or equal to 2. So now I'm going to look at this and see what the domain of my final answer is. Is that still x is less than or equal to 2? And the answer is yes. So that's my domain. My domain is just x has to be less than or equal to 2. Or if you did interval notation, you would do that. Second part, g of f. G of f would look like the square root of 2 minus the square root of x. Right now, the domain, I can't really simplify that either. I'm kind of just stuck right there. Okay, so domain, I need the domain of f. The domain of f, which is up here, because it's just an x, the domain of f is x has to be greater than 0. I'm going to combine that with the domain of my final answer right here. Okay, my final answer. Remember, I cannot get a negative number in here, which means I cannot subtract more than 2 from that initial 2, because 2 minus 2 is 0. I can't have anything bigger than that. So to get a 2 and for the x, I'd have to have square root of 4. I'm just talking here. I hope this is making some sense. So no matter what I put in, must be less than 4, because, well, I'll show you if you want me to. This right here, this inside part, must be greater than or equal to 0 also. So if I were to take this over here and leave that over there and then square both sides, all of a sudden I'm getting 4. X has to be less than 4. So my final domain is going to be less than or equal to 4 and greater than or equal to 0. So that's my domain for part B. Part C, f of f. This is kind of a weird one. I'm actually going to take function f and plug it into function f. So it would be the square root of the square root of x, which we've already talked about. If you have 2 of those, it's really the 4th root of x. And then a domain. The domain of regular f, of where I started, is x is greater than or equal to 0. Match it up with our final answer right here. Does x still have to be bigger than 0? Yes, it does. So there's your domain. Because I ran out of room, I'm going to save that one for tomorrow, the g of g, but it works the exact same way. Okay, a little bit of thinking there. Sorry about that, but sometimes you got to do it. It says, given that f of x equals 4th root of x plus 9, find functions f and g such that, okay, here we're going backwards. I think this is a lot of fun. I don't know if you will or not, but it's pretty cool. If f of x equals the 4th root of x plus 9, they want you to find a function f and a function g, so that if you did f of g, you would get what we started with. So I got to find some function g to plug into some function f that would look like what I started with. So here's what you're not allowed to do. You're not allowed to just use x. You got to do something fancier than x. What I'm going to do here is I'm going to let f of x be the 4th root of x, and g of x, I'm just making this up, guys. I'm just playing, okay, be x plus 9. Now think about this. What if I try to do f of g now? Okay, I'm doing a composition of functions. So it means I'm going to plug this into that. And if I do that, does it equal that, what I started with? And the answer is yes. So there you go. There's no huge strategy here. There's no big method I can give you. It's just thinking it through and trying to come up with two functions that'll work. And you can't just use x because that makes it really easy. All right, man, that's a lot of stuff in this one. We'll work on it tomorrow. You will get it, I promise you, but you got to really pay attention and may want to watch this one again. But I'll see you tomorrow.